Very much. A good day to everyone. Many of you had joined yesterday. Let me first start by sharing my screen. So today is the second day of our free workshop for the course of DevOps with AWS. Yesterday, what we did, the notes have been posted and also the video recording of the session. So yesterday, we discussed about the syllabus of the course. We did a real-time hands-on lab practical of the course. And we learned a few basics regarding the initial stages of the course that you need to know. Now, today's agenda, let me be clear on this, what we are going to start today. So today we are going to have some theory session. This is a very preliminary thing, which you should know. This is particularly for the beginners. That is something called SDLC. Software Development Lifecycle, and we will discuss about DevOps. Like what is DevOps actually? What is SDLC? What is DevOps? And then we will do a hands-on lab practical as well. Now let me get straight into it without wasting time. So the first thing is SDLC. SDLC. Software Development Life Cycle. So it is cyclic process. It goes on and on. It never ends. So let us understand regarding SDLC, the key aspects that we are going to learn is what is it? What is SDLC? Why should we use it? What are its various phases? It goes through phases. And then what are the different models? People who have studied graduation in their graduation, who have studied IT, who are at least, even if they are not doing any job, they would already have this, at least it was part of their course. And it was part of the theory part. So most of the people actually don't pay attention to this. But the thing is, everything in IT starts with SDLC. There has to be some software first. Only when the software exists, if it does not exist, it will be created, it will be built. But if it already exists, then the cycle for its continuous maintenance, enhancement, bug fixing, that happens. Okay. So without SDLC, there is no IT industry. So you should, the core concepts that I'm giving in this class, that would be enough for beginners to begin your DevOps with AWS course. But you should definitely know about it. Otherwise, you will not be able to see the big picture. Like in totality, what are you actually doing? So let me move ahead. So SDLC or Software Development Lifecycle, it refers to the key points for SDLC are planned designing of software. What we are talking about here is related to software only. Suppose there is all businesses will use softwares for earning revenue. Okay. Just for example, let's think about any telecom provider. Okay. So we know about Airtel. It is one of the major service providers in India. Now, if we check this website, this is a web app. See, right now they are coming up with a plan, something called Airtel Black 1099, and then it has got certain features. So what is this? This is an idea. That is that business. It all starts from an idea. Business sees that there is an idea that if it converts, if it converts that idea into a product, and then if they release it in the market, they will earn revenue. So for business, the most important thing is how fast is that idea going to get converted into a product, and then how fast that product can be deployed into the market. Now, this is where softwares are required and software engineers are required. Now, if software is required, then that software will have to go through a life cycle. It will have its own life cycle. That is why you need SDLC. So this was just a small, just a real-time example. Airtel has come up with this new plan, along with the broadband, with certain speed, with unlimited features. It will give TV channels. It will give other apps like Prime Video, Hotstar, and rest of the stuff. So all of these things, business has done some survey. It has done a survey where it has seen how many, what its competitors are providing and how they can capture the market so that they can earn more revenue. But then to maintain this software that you are seeing, this Airtel.in, and then this is the website. If you see closely, it is using HTTPS protocol. It has got a secure connection. It is using cookies. It has got settings. If you check the certificate, these are its security certificates. Okay, why do you need this certificate? Because you will be transmitting data. If you try to log in, you will be entering your personal data. Now, Airtel, as the owner of this website, so Airtel is the business. Now, business owns this website. If they want to gain the trust of the customer, they need to make sure that their web applications are secure. So once again, what do we have? We have got software, and then it has to be designed in a planned way. So SDLC is nothing, but it refers to the planned designing of software, which is evaluated systematically. After each phase, it is evaluated according to certain protocol. So before we go ahead, we will repeatedly come across this term, protocol. What does protocol mean? Protocol is nothing but a set of rules. Okay, a very simple example is, suppose you purchase, this is me here and this is Amazon. Okay, now if I want to purchase something from the Amazon website, Amazon has certain set of rules. Like when you are ordering, you definitely need to log in. You have to give some data, personal data. Amazon has set these rules. I will also agree, only then I can do the transaction with Amazon. I will now, for the payment, you can do cash on delivery, or you can do pay through net banking, or through cards, credit cards. So these are once again the protocols. Okay, so here the protocol is either you pay the amount when you receive the product, or you pay the amount before receiving the product, and then Amazon will ship the product to you. So these are the set of rules for the transaction to happen successfully between me and Amazon. If any of the set of rules here is broken, either I don't make the payment when I receive, I choose cash on delivery, and when the delivery guy has come, somehow I did not pay the money, then he will not provide me the product. But in another scenario, if I have paid the money, I did not receive the amount, then Amazon will have to revert the money back to me, because Amazon is not following the set of rules in that case. So whenever two parties interact with each other, A is interacting with B and B is interacting with A. Okay, in this case, A was me and B was Amazon. But now when you come in the context of SDLC, A will be can be a user, B will be the software. Or it can be a software interacting with another software. Okay, so whatever it is, whenever two entities are interacting with each other, they need to interact to make the transaction successfully complete. They have to follow a set of rules. Now, that set of rules is nothing but protocol. That is what is termed as protocol. Protocol can be in between two softwares also. Okay. For example, when I am trying to, so this is my Windows PC. Now I create a remote on my cloud using AWS. I create a EC2 instance, which I showed yesterday. I create a remote server. Okay, so my Windows PC, this is my local system. And this PC is present in Hyderabad. In the city of Hyderabad. But the remote server, maybe I'm creating it somewhere in Virginia, in USA. So it's one of the regions of AWS. So it's a remote server. Now from one geographical location to a different geographical location, you are connecting. But then how does the AWS server, the remote server, know that this person is the authenticated person, it is the right person? Anybody may access that. But then that security, so for security protocol, so security protocol will be used here. So security protocol, networking protocol, all the, so there you will come across this protocol word multiple times. If you remember yesterday what I did, to log in from my local desktop to a remote server, I used something called PuTTY. And in that, I used the SSH protocol. Okay, so protocol is something which is nothing but a set of rules. Remember that? And you will always keep coming back. I mean, like you will, this is something contextual. It will vary from context to context. But then every time, as per the context, there will be certain set of rules. And that will be the protocol applicable in that case. Okay, so let me get back to the SDLC thing. Main idea, the main objective for any business is to always keep it in mind, whichever company you are working for, either they would have their own products or services, or they would be providing software services on behalf of some other company. Okay. Whatever it is, ultimately some customer is actually paying, and they are paying to get their idea converted to a product, and then that product has to be deployed to the market. And as soon and as quickly they can do it, they will be more competitive, they will be spending less amount of money, and they will be gaining more business. So idea to product to market, and then earn revenue. This is the objective of all businesses. Always keep that in mind. So here it will be a little bit abstract in software because here the products are not something physical. Okay, so for example, if you all check your net banking pages, whenever you log in, you will have many kinds of products listed there, like demat account, loan against gold, or maybe credit card, or maybe fixed deposits. Okay, these are all the products. These are not physical products, but to provide these services online through a software, there has to be coding. There has to be software which is written. And hence, again, we come back to the concept of SDLC. Wherever there is software, there will always be SDLC. So as I said earlier, SDLC refers to the planned designing of software models, which are periodically and systematically evaluated after each point. And it is done based on certain protocols. That's it. Just keep that in mind. So let us now go through the phases, SDLC phases. What are the major phases? I will go at a very high level. I'll not get into much detail here. This we will learn in subsequent classes. Today, keep in mind, all the things are just being discussed very briefly to give you a very high level overview. So everything in the SDLC process starts from planning. First of all, you will plan. And then, okay, actually I should not draw it like this. It is cyclic. It starts with planning. And then once you have planned something, you have to define it properly. Once the definition is done, okay, fine, this is what I exactly need. You have finalized. For example, this is, for example, some planning had been went in here. Like when this web page was being designed, like what has to be written here? What will be the drop-down values here? Like this is the menu bar. So Airtel Black, prepaid, postpaid, broadband, all these had been planned earlier. And then finally, it was defined. During their planning phase, they might have come up with 10 different menu bar options. Okay. But then finally, they had many meetings and then they finally finalized on something. That finalizing was the definition. Now, then they did a mock-up. Okay, so this is what we want it to look like. This is how it should look like and it should work. Under each drop-down, whatever respective values they have decided. So that is in the SDLC, the software development lifecycle. That second part is your defining. Once you have defined it, then you have to start designing it. It is very logical. It is not difficult to understand. If you go step by step, you will see that it is very logical. Then you will have to design the structure. And then, so designing the structure is actually building only the empty shell here, like this web page, like this text box field where you can put in mobile numbers. So if I try to put in, what I'm trying now from my keyboard is, I'm trying to type in ABCD. So it is not allowing. But if I type in numbers, it is allowing. And then I have more than 10 numbers, it is not allowing. So this is your designing. This part is the designing thing. Okay. Once it is designed, it has to be also built. Like in the designing, these things were input. What? Like it should not contain more than 10 numbers. ABCD will not be allowed. Other characters will not be allowed apart from 0 to 9. Okay. And number should not start with 0. Okay, it is allowing. I don't know why. So this is a problem in their side. No telephone number starts with 0, 10-digit number. Okay, this part in the designing they have missed. Things like that. So see, this is a miss from their part. But then we will see after designing, we are going to actually build the website. Okay, after building, then it has to be tested if the thing is working properly or not. Okay, so what happened here? Somebody has actually not checked it. No telephone number starts with 0. We know that. So this part they have missed. But then once the testing is done, so this was supposed to be done in the testing part. Once then you actually deploy it. When you say deploy, you actually mean deploying it into production so that everybody can, all the customers, intended customers can actually start using it. That is called deployment. And once it is deployed, now this site is up and running. Now anybody who has got who is a valid Airtel customer, they can put in their Airtel number and then they can log in. Once they put in the number, they will get some OTP. So all this went into the building phase. Okay, but that the thing that the customer will be authenticated using a mobile number OTP, that went in the design phase. And then finally developers did the coding. That was the building. Once the developers did the coding, they gave it to the testing team just to for them to check that each and everything is fine or not. Okay, they will put dummy numbers. They will check if on clicking the send OTP button, if it is actually working or not. After clicking on the button, are you receiving the OTP or not? That part goes into testing. Okay, once the testing is done and everything is ironed out, like if they find any error, then the testing team actually will send it back to the developers. Do the checking, like check your code. You have made some mistakes. They will rectify the code and then again they will send it back to testers. So this cycle will go on till the time they have ironed out the issues, figured out like the bugs. These are called bugs, software bugs, when the software does not work as intended. For example, the software here should, whenever a 10-digit number, a valid number is put in, this send OTP button should get highlighted. And then on clicking on the send OTP, the mobile number, which or the landline number which has been input here, that will receive the SMS. Okay, for validation. So all of that is now once all this thing has been tested, it needs to be put into a live environment, which all the customers can use. That live environment is called production or prod. This word you will always keep hearing. Okay, that is the real environment where the software is actually being used. Now, once the software is deployed, you need to maintain the software, right? For example, if you buy a house or buy a car, maybe you spend, let's say, 10 lakh rupees on buying a car. Do you think, I mean, like after buying the car, after spending 10 lakh, there will be no other intervention required from you? I mean, like I'm ignoring that the cost of petrol or diesel. That is a fuel cost that if you whenever you are using car, you will definitely have to spend. But apart from that, you will always also need to maintain the car, right? Regularly, after maybe, let's say 5,000 kilometers, you will have to get it serviced. Check the oil, check the air conditioner, check the tires, check the gear system and whatever. So you will have to get it serviced. So what I'm trying to say here is, once some product is up and running, if it is working properly, the next important part that comes up is nothing but maintenance. In software terms, what does this mean? Maintenance. In software terms, when you say about, when we talk about maintenance, it means providing the support. So all this software, if you think this Airtel's website that you are opening, which has got so many different modules, they are all hosted on different servers. Okay, those servers are deployed. There are databases, there are application servers, there are web servers. There are thousands and thousands of lines of coding. Every day, customers, lakhs of customers are using this website, maybe to log in and check their account, pay their bill, or maybe to subscribe to a product, or maybe to change their plan, or maybe to discontinue their service. Okay, so all of these things are happening through the website. Now, during the daytime, during the peak usage, the servers are handling lakhs of requests. Now that will create, it is highly possible that one or the other time, I mean, like if there are 1,000 servers, one server will go bad. It is very much possible. Okay, that needs to be monitored. Okay, so that part comes under maintenance and monitoring. And if there are any issues, if one server is down, then quickly mitigate it. Spin up a new server, make the old server redundant. Okay, and then the databases need to be refreshed because they are handling millions of transaction requests. So they need to be cleaned up. So usually this will happen during the night time, around 3 a.m. So when 95% of the users are not going to use the systems. Okay, I hope it is making sense. All this is actually, these are the phases of SDLC. Now, during maintenance, then you observe, for example, this is actually a bug in the system where it allowed you to, it's a very minor bug. The first letter is starting with 0. I don't think any 10-digit number should start with 0 at all. Okay, so this needs to be rectified. So during the maintenance period, this can be reported. And then again, this cycle can again be started. That in the next phase, next iteration of the, so all this was done in iteration 1 project. So this was a software project. It goes in iterations. In iteration 1 of the project, it was decided, planned, and then defined that maybe in this phase, what we are going to do, we are going to make 30 enhancements. Okay, 30 enhancements, they will be defined, designed, built, tested, deployed, maintained, and then during maintenance, they will, maybe they came up with certain issues. During the testing phase, it is not possible that all the 100% bugs will be addressed. That is not possible. Errors can creep in. Okay, maybe it was missed by the testing team. It can happen. Okay, so then that thing which was missed, that was observed during maintenance, that will go into the planning phase for the second iteration. Okay, so these are the major SDLC phases. This is what happens in the life of any software. Now, let me see. So this is like at a very high level. I will actually encourage you guys, if you have any questions, like very basic questions related to this topic, please feel free to ask now before I change the topic.
Sir, enhancement meaning, sir?
Enhancement. Yes. Okay. So see, in SDLC process, see, keep in mind, there are other things. This is just a demo workshop. The entire thing has not been discussed. I have just given a brief idea. For softwares, sorry. In the SDLC life cycle, a software will go through like iterations, okay, or you can call it build or release. Okay, so in the initial phase, in iteration 1, it will go through this process like iteration 1 and then 2, 3 gradually. So what is happening? The software is getting updated. Now, there are 3 things for which you will do the iteration. What? One, the first thing, why you will, if a software is already built, why do you want to change it? Maybe you want to add new features. Okay, or what in other words is called enhancement, add new features. Or you will need to fix bugs which have been issues which have been found out during the maintenance phase of each iteration. Okay, once it is already deployed into production. Or the third thing that you might require is actually to upgrade. Upgrade what? Not the software. Upgrade the platform on which the software is residing. Okay, for example, the server or servers on which this, but maybe, for example, where the Airtel website is hosted, let's say it is Red Hat Linux. Okay, they are Red Hat servers. Maybe all the servers are not Red Hat. Okay, then these Red Hat operating systems also need to be upgraded, right? Operating systems also need to have patches. So that is the upgrade. So there are 3 reasons why you will need to make changes to any software. Give me 1 second, please. So that is regarding the enhancement. I hope, I don't know, there are many names here. I'm new to all of you. So if there is anything, who asked, I did not make it out, but I hope that answers your question. So basically, let me give a quick recap here. The phases of SDLC will mean planning and requirement analysis, defining the requirements, designing the software, developing the software, then the software testing, then the deployment and maintenance of the software. Okay. Now, on that note, I think I will let it go, because this will again have to be taught in detail. Okay, this is all the things I cannot, this is a very high level overview what SDLC is, but you should definitely know this. This you need to know before I start the next topic, that is about DevOps. Now, before I get into the next lecture, I think it would be good if I show some practical as well today. So let me give a brief pause in the lecture. Otherwise, it will become a bit tedious and boring. So now I'm going to do a lab, hands-on lab. Let me give you a brief idea about what I'm going to do. So let's say there is a company. Now I'm actually changing the topic. Okay, that SDLC thing that we have learned till now, that was the basic idea we require for understanding. My intention is to actually discuss the DevOps thing as well. Let's see, if time permits, I will definitely try to do that. But before that, let me give you a lab demonstration about how things, because practicals will be a very major part of our DevOps with AWS course. So once I am done with the practical, then I will try to address, teach you the DevOps basics also. Okay, so the lab that we are going to do is, let's say there is a company, Acme Incorporated, and they are maintaining, they sell products online. So let's say they have got 3 websites. Three separate websites they have. Okay, what I'll do is I will name them like website blue, website green, and website yellow. Okay, now maybe because of the company management, they just for example, in the last 2 years, we had the whole entire world went through a phase of COVID, and that directly resulted in business loss. If there was no sale, automatically there was a loss of business. So now the management from the company, what they want, let's say they are like spending $200 per month for the maintenance of each website. Whatever servers are required, databases are required. Okay. So in this case, let's say each of them are being hosted on a single EC2 instance. Separately, 3 separate EC2 instances have been deployed. Okay. Each of them is costing monthly $200. Now, management has come up to the IT team and they are asking us, boss, reduce the cost. We are suffering business loss. Then the IT team, this is the task given to the DevOps engineer. So now we have to provision. The DevOps team will have to then figure out how can we. There are already 3 websites running on 3 separate servers. Company wants to reduce cost, so they come up with the solution that instead of running 3 separate servers, we will merge all the 3 servers into 1 server. Okay, and we will run all the 3 websites from 1 server will handle 3 websites. Okay, this is a real-time scenario. So what will happen then? Then we can terminate these servers, and instead of that, we will maintain only 1 server. Instead of in a combined year, where company is having to spend like $600 per month. So instead of that, for keeping 1 server alive and running, we can spend only maybe $300, because it has to be a little bit powerful if it has to handle 3 separate servers. So all of this using the AWS cloud infrastructure as a service we can do. So first of all, let us quickly deploy 3 separate servers. Okay. Let me go ahead and do that. For that, I need to log into my AWS account. Okay, this is mandatory, guys. Please log into, create your AWS account. That is a mandatory thing for this class. You definitely need a computer to practice on. This course cannot be learned through mobile phone. You will definitely need a computer to practice, whatever be the computer. And apart from that, you will definitely need a AWS account. For people who already have AWS, I will still advise them, please create a new one. If it is, because we are going to use the AWS free tier. Now, if you create a new account, then for 1 year, many of the features that we will be using, that will be free. Okay. If you already have an account, so 12 months, for 12 months, you will get many of the products free. And those products are more or less good enough for us. Okay. like storage 5 GB up per month. For 12 months, you can use S3 service up to 5 GB. EC2 up to 750 hours per month in total, you can use for free. But if you create, that is only if you create a new account. But if you're trying to use a existing account, maybe it is already 9 months old or 11 months old, you will not realize it. And then what will happen? You will be charged a bill for that, for anything you are using. So my advice is to see many of these things are free here. Okay. And we will be using these free features only. That is good enough for us to learn and study and implement real-time practical projects. So please go ahead and sign up for this. Let's see, I'll have to search. I will provide a document, a PDF document, which you can use for people who are new. You can actually use it to sign up. There will be like one-time charge. Like in India, it is only 2 rupees because you will need to put in some card details. Please make sure, I mean, like you have a valid credit or a debit card. Okay. Okay, somebody is asking, like Karthik is asking to use Linux commands. So Linux is the heartbeat. Without Linux, you cannot do anything here. Okay, so everything happens with Linux only. So let me launch an instance here. Hold on, let me actually check what websites do I have already. Let me go to the dashboard. So there is only one instance which is in a stop state. Fine. So let me launch an instance. No, let me give it a name. So this server is for website yellow. I'm going to choose Red Hat Linux as the operating system. The instance type is T2 micro, and I will create a new key pair. Let me think. Actually, the matter will be same, so I will rename it later on. So blue, green, and yellow, and finally the integrated also. I will use the same key. I will use the same key to log into all of these servers. So it's the .ppk format that I need, because this .ppk format you only need when you are trying to log into a Linux remote system from a Windows system. So let me do that. It downloaded that file. Okay, I will be creating 3 instances. And now let me edit the network settings, because I need to allow certain things. So I'm going to use a default VPC, subnet is fine, public IP should be enabled, a new security group will be created, and I need to allow HTTP and SSH traffic. Otherwise, it will not work. Okay, so here, see, I was talking about protocol. These are the protocols. These are the network protocols here I defined. I need the SSH to log into the EC2 consoles, that black screen that we are going to see shortly. And HTTP is for the to be able to open it in the browser. So these are just 2 protocols which I defined right now. And for each server, 10 GB of storage space is defined. Okay, and earlier when I had chosen that this instance type T2 micro is already chosen, so it has got 1 GB of RAM and one CPU with low to moderate networking capacity. Okay, so if you click on compare instance types, you will see all the kinds of computer builds that you can choose from here. Okay, so this is like ordering servers from China. You can, I mean, like if we had to do this on premise, then all these computers, like see, you can go as much high as you want. Like see, like C5A 16x large. This is what typically are used by businesses. So this has got 64 CPUs. It has got 128 GB of RAM, and its network speed is 20 gigabit per second. This is a very, very powerful machine. Okay, and then even higher, 96 CPUs, 192 GB of RAM. Like this is a tremendously powerful computer. Usually, but then businesses also earn in millions, right? So they are okay to spend thousands of dollars on servers per month because it is a working system for them. But right now we are not going to do that mistake. Of course, we are going to be happy with T2 micro in your interview, but never say that you have used T2 micro in your real-time projects. Like in any business organization, no business uses such weak computers. This is only for training that we are doing. Okay, keep that in mind. Okay, so our operating system is defined. This I will change again. I have kept a common part as the name, and if you can see, I'm going to create 3 instances for blue, yellow, and green at the same time. And here we have our key. We have allowed the traffic. We are going to create a security group. All of them are going to use 10 gigabits of resource. So this is good. Let's click on launch instance. So now if you see the details, there are 3 links here. Amazon has created 3 separate instances. Each of them has been identified with a unique Amazon resource name. This name is nothing but I stands for instance, and then a hyphen, and then this is a hexadecimal numeric code to easily identify. These are unique. No other EC2 instance will have, no 2 EC2 instance in the world will have the same ID. They will always be different. So if I go back to click on instances, I can see that these 3 instances have been created. They are in running state, but they are the status check. If you see, they are still getting initialized. So now let me quickly rename them. So let this be blue. Let this be green. And let this be yellow. So this is what our business requirement is actually. No, right now I have to create these 3 websites first. I will make them running, but then our business requirement will be to put all these 3 websites into a single server. Okay, maybe we will create another one. We will call that integrated. Actually, I should do that right now. By the time these 3 will be in our working state. Websites integrated. This is our solution server. So again, the rest of the things I will keep same. Red Hat Linux. I will use one existing key, which one I just now downloaded. BGY integrated. This is the one that I will be using. So once again, here SSH and HTTP traffic needs to be allowed. And 10 GB of storage space. That is enough. So let's go here. as we can see now, the website's integrated is in a pending state, but after some time, when we refresh it later on, this is in a pending state now. This will get into running. Our other three EC2 instances have gone into a running state, but their status check is in an initialization state. So let's wait for that a little bit, because now I need to log into each server and make them working. So how did I do that yesterday? I will use putty. So all these servers have been created in the Mumbai region. Okay, you need to make sure which region you are working in. AWS provides you a lot of regions based on the demand of the customer. So if your customer is based in Japan, then you should have used the Asia. Then I would not have used Asia Pacific. If the customer's base is in Japan, then I would have used the server Asia Pacific Osaka. Okay, so this is what you need to make sure. Okay, Osaka or maybe Tokyo. Both of them are in the Japan territory. Okay, so let me, I'm just waiting for it. Okay, so 3 of the servers have done a health check pass. Status check has been passed. So Amazon has checked it in the background. They are all working fine. So now let me log into each web server using putty and using the SSH protocol authentication. So for that, I will have to give them a key. So I'm going to use this key. So the first thing that I'm going to do is actually I'm going to rename this. This was the website blue. This server is for website blue. So let me actually rename this using a command called export. This is the command. Now what I'm doing here is I don't want to keep this lengthy command here. All of the, by default, all EC2 instances created, by default, the username will be EC2 user only. Okay, but then this is, for now, I'm going to deal with 4 putty consoles. It will become difficult for me. So that is why I'm defining my name. But this is only a temporary name. So I'm just naming this blue. This is for website blue. So now if I keep pressing enter, instead of getting this $sign, I will keep getting this name. So I know which server I'm going to work on. Similarly, okay, so let's do one thing. Obviously, if you're trying to do website stuff, you need to install a software. What software is that? First of all, the command is DNF, and then its parameter that you need is DNF install. I need to install the HTTPD software, and I will do it with -y. I need to do this in all the 3 servers. Okay, so let me actually do one thing. Let me log into all the 3 servers at the same time. And the same command then I can copy and paste and put in. So every time see now I'm trying to get into the green website green server. So the IP address, I have checked this green website, and then I'm taking the public IP address of the green website server, EC2 server. All of them will have different IPs, okay? But to keep it simple, they are using the same key. This PPK file. This is the authentication file. So this is the second server actually. Which server is this? This is website green. So what I'll do, I will rename it. Export PS1 equals double quote what was this? Green. There you go. And then finally, why I am logging into 3 servers at the same time is all of them need the similar website structure. So then I can use the same commands one after the other in the 3 servers. So this is once again the third website for yellow. Copy this, open a new console, log in using SSH, use the key. This is the private key for logging in. And finally, you have got the third website. The third EC2 instance. Let me change its name to something which I can identify it with, because all of them are black, all of them are going to have EC2 user. So blue, green, and this is finally yellow. So now it will be a lot easier for me to understand which server I'm working in. Okay, so if you check, this is blue, this is green for website green, and this is finally for website yellow. Now I need to install the HTTPD software in all of them. So I will do it in one shot. While it is doing in this, in the other ones also, I will paste it. Okay, so in the blue server, it is completed. Now, obviously, after actually, let me clear the screen. Let me change the setting also. So after installing HTTPD, we also need to start the service. So for that, you are going to use sudo systemctl. For people who are new to Linux, don't worry. We have sessions, multiple sessions for learning Linux from scratch. Sudo systemctl. Now we need to start the service. Which service? HTTPD. And then finally, let us check status. So status is working fine. Okay, same thing we need to do on the other servers also. So this one I did for blue. This one is green. So I'm just copying the command here by highlighting it. I'll do Alt tab and I'll check. So in this one also, it is blue and green are working fine. Remaining is yellow for the yellow website. So once again, let me do the start HTTPD first. Oops. So only the yellow one is remaining. And then finally, check the status. Yellow. Yeah. Systemctl status HTTPD. So all my 3 screens are, all the 3 servers are running. So what does that mean? Then I should be able to, for all the three servers, website blue, green, and yellow, I should have, let me actually open up these servers individually. The Apache test page. So this is for website blue. Let me quickly check. The Apache test page should actually open. There you go. So this is for website blue. Just go look at the IP address 13.232.126.157. This one is for website green. All the IPs will be different. They cannot be same. So let us check. Here also we should get the same Apache HTTP web page, test page. So it is working. And then finally for website yellow. So this one is again 13.233.146.211. It's a different IP. Okay, so this one is 211. This one is 157. Just see, all of them are. This is 157. 157. I mean, like this is 3.110. It starts with, but here it is 13.232. Okay, so all these three are public IP addresses, and they are all working fine. So this is the current scenario. Three websites are working with monthly total cost of $600. But now our solution server, to reduce the cost from 600 per month to 300 per month, we will put in the three websites into one server. Okay. But then, yeah, one thing we did not do, there is no website actually. That I forgot. So if we want our own website, cd root var, if you remember, if you need, this is only a test page. If you want your own website, then you need to deploy your index.html in this path, in this particular path. Otherwise, it will not work. So let me quickly go ahead and do that for all the three blue, green, and yellow websites. The path is this. So first of all, I will change directory to that path. Then I will check if I am in that path or not. Okay, fine. Now currently I am under the HTML directory. I am under the correct directory. So let me clear this up. Now I need to write a index file. Earlier in yesterday's class, we deployed the index file in a separate location, and from there we pulled it. But now I'm going to directly write it. It's a small application, so I'm going to directly write the code for the application in this. So sudo vi. So don't get confused here. I have got three separate websites. Website blue, green, and yellow. So for each of them, actually, let me do it in a separate page. So I have got three websites, blue, green, and yellow. They have got their own servers. They are deployed on three separate servers. So this is for blue. I paste it. No. So this is the IP address for website blue. This is the IP address for website green. See, all the numbers are different, so don't get confused here. It might look like the same page, but once I put in the code, you will see the pages will have different content. And finally, this is my third server. Okay, so they are all working on, see, now understand the protocols. I have used two protocols, SSH, correct? Okay, so I have used two protocols. One is SSH and the other one is HTTP. HTTP uses port 80 and SSH always uses port 22. Okay, so see, I have to use that is what I added in the beginning while creating the EC2 instance. Because if I would not have added these ports, like for example, if SSH would not have been added, then I would not have been able to use this console. This console is using port 22 or SSH. Similarly, now for the browser thing to work, that will work on HTTP. Okay, so that's why these two ports, see how the things are adding up now. Now, what I was earlier saying is, Blue website will have its own index.html. I'm going to create 3 index.html files, but they will be in their own respective servers. That is where I'm asking you, don't get confused. They will have their own individual coding and they will be separate from each other. Okay, this is what I have created the 3 servers. I've logged into them. I've deployed the required software in all 3 of them, which is nothing but Apache HTTP server. This is the software. That's what I installed in all 3 of them. Okay, and then finally, and now I'm in the process of creating the respective index.html files. So that why we want, it is our own website. We will write our own, I mean, like company wants its own code for that. Now, once again, this part is not DevOps engineer's job. This one I'm just doing now for explaining it to you guys. Okay, so don't worry about this part. This is just so that you understand what is happening. So let me go one by one. So I'm in the Blue website console now. Let me create the index.html file here. This is the Blue website index.html file. This is what file, this is the file which will contain the data. Okay. So let me insert, I already have the code. I'm not going to write the entire code. :WQ, and there I have written the code. So now if I go to the website, this is for Blue. And if I refresh this page, so it says, welcome to my Blue website. This is some sample text. Similarly, let us do it for the green and yellow servers also. So now I'm in the green. So see how I was doing each and everything step by step. The fonts might look very small to you. Let me increase it. Okay, so BI is for creating and then editing a file. It can be used for both. If it is not there, it will create. If it is already there, then it will start editing. Sudo is a command which regular users need to use if they are altering any system. Okay, so this is like accessing with administrator privilege. That is why I'm writing sudo. All of this you will learn later during the Linux classes. Don't worry about it.
Sir,
Yes, you can call
sir,
me
please
Kallol.
tell about important Linux commands for becoming DevOps engineer, sir.
See, your command will depend on what you are trying to do. Okay. When you say important Linux command, any command can be important. What exactly you want to do? So gradually, the syllabus has been shared with you. You have received the syllabus, right?
Yes, sir.
Go through that syllabus. Initially, we will be learning from the basics, and then gradually we will be writing scripts, because initially we will be doing things manually, but then we will have to automate. And for that, you will need to write the scripts. So gradually, as we progress the lab sessions, every day you will be using Linux. You can't learn all the commands in a single day. Okay. Gradually, you will understand. So now I am creating the index file, index.html file for the green site. Get into insert mode, do a right click, escape, :WQ. So this is also deployed, which means if I refresh the green website page, that should also work. This is also working. And similarly, the final one. Actually, I can use this same command. So this is a way of copy pasting. I mean, like if you only simply highlight, it will get copied. And if you do a right click, it will get pasted. The final website happens to be for the yellow website, the yellow website page. Okay. So now I save it. Done. Okay, so we have got our blue, green, and yellow websites. So see, basically, I don't think we have got sufficient time to complete this task. But then what I showed you right now is how to very simply spin up a EC2 instance remotely. You had the ability to choose your own operating system, your own your hard disk size, how many CPUs you want, and then so quickly you can easily deploy. So for us, I mean, like if it is a web-based application, then all this code is not supposed to be handled by us. The development code, I mean. Okay. Instead of this thing, I mean, like it could be something like this also, a very complicated code. This is only for demonstration purpose. That's why I put in very minimal code here. Okay. So instead of this, let me change the code here. I actually need to discuss about the DevOps thing also. Otherwise, you will not get a high level picture. So let me end the lab session here with a final demo. See, this is such a lengthy code. So all of this code is actually going to be provided by developers. So we don't need to worry about that. Our job is only to deploy this code in the correct location. So now if I just quickly change this code and it has got saved, the yellow website will now look very different. So this is what the earlier code was doing. Now if I refresh the page, now you've got a completely different website. Now earlier it was just a static page, but now it has got buttons. How many times? It has got 5 buttons with 5 different colors. The background keeps changing. Now there is a username admin box here. You can actually try to log in using this. So don't worry about, so again, I'm saying this kind of code stuff. Okay, I click on login and it gives a message. This kind of stuff is development code work. This is not supposed to be, this is not DevOps engineer's job. Right? Now, for time's sake, I actually have to now get into the DevOps thing. Now we can continue this lab later on. There is no problem in that. But for the time being, now to end today's session, let me give you a lecture on what exactly DevOps is. Some of you might already know about it, but I'm pretty sure many of you guys don't know at all what it is. Because many of the questions we have faced yesterday, they were asking what can, as a fresher, I join DevOps course with AWS? Yes, you can, because you will be learning everything from beginning. So consider this your first class for concept of DevOps. So what is actually DevOps? Very simply put, this word has got two parts. Development and operations. Okay, so that's why it is, if you see, DevOps is written like this: DEV, D is capital and then O is capital. Okay, so let us try to understand it in brief at a very high level. So what we are going to discuss to understand DevOps, there are a few points. I'm giving you the major points that we are going to discuss. We are going to discuss something called application release process. Then we are going to discuss the challenges that DevOps solves. What was happening earlier and how DevOps actually solves that problem. Then we will discuss a few principles of DevOps. Let me start with this only first. Okay. Now, before I could discuss application release, now go back to what you have. Let me actually quickly go back to the previous slides. We discussed about SDLC, right? So why phases, models of SDLC we have discussed. Not the models, actually, then it will become like a 3-hour session. This model thing was not discussed because of insufficient time. But what, why, and the phases. This part is important. Ultimately, always remember the business idea has to be converted to a product and the product has to be released into the market. And for that, you need software support. And that is where in the software development lifecycle, DevOps is one of the newest methodologies, which right now, it is the best, one of the most efficient methodologies in practice. Okay. The reason being, there is a group called CAGR. You can Google it. These are the guys who actually do a forecasting for global markets. So right now, their global market forecast, around 2020, DevOps revenue was around $26 billion. But now by 2027, they are expecting it to become 22. I mean, like in the margin of $21+ billion. Okay, this is in billion. Billion means there are 12 zeros. After writing 6, there are 12 zeros. So this is the global market for the CAGR. You can Google it later on. I mean, like IT companies actually depend on reports provided by these kind of companies. Okay, so if you check the graph for DevOps, it has already a methodology or software only becomes relevant, only becomes important when the community starts using it. So right now, the DevOps tools and principles that we are seeing, it is growing like this. Okay, but compared to the demand, the demand is very high. the demand for DevOps engineers, that is higher than available engineers. And because the demand is higher than the availability, that is why the salary is also higher. Salary is also greater than normal software engineers. Okay, because normal software engineers can be developers, testers, they can be freshers, they might be working in operations teams or in support roles, whatever be their job profile. The people, the software engineers who are learning DevOps additionally, they will have a far better scope and far more, they will have a cutting edge compared to other people. Why? For that, let us understand what exactly happens when a software in a software development life cycle, and what are the problems that usually happen in the normal process, and then where DevOps actually fits into this picture. Okay, so broadly speaking, if SDLC is a complicated process, okay, first of all, it involves many people, many teams. There is interaction between these teams, which creates conflict. Okay. Why? Because the boundaries for the work boundaries are not properly defined. What I mean by this is, for example, where does the job start? Where does it end? Now, as a DevOps engineer, now, for example, the traditional way for working in a SDLC process is very simple. This is traditional SDLC process without DevOps. Okay. What is it? There are two teams. Majorly, there are two teams. One is the development team and one other is the ops team. Okay, so all testing, all deployment, all of this gets clubbed under ops. But majorly, it is the deployment. Okay. Right now, this is the boundary. Developers will develop the code. They will write the new code, and ops team will test and deploy the code. Once that thing is done, that will be pushed into the production, or in other words, it will be handed over to the customer. Okay. Now, in this traditional model, first of all, as DevOps engineer, you are going to get into this traditional model. So there, that boundary, the first confusing thing is understand, like you will be somewhere in between. The DevOps engineer is actually somewhere in between the dev team and the ops team. This is where you will be, okay, in this common spot. Which part of dev is not DevOps? What part of ops is not DevOps? Let us try to understand that. But then, again, keep in mind, what is the final objective of all of this complication? The final objective is business had an idea, which is nothing but their business requirement. That idea needs to be implemented into the market as soon as possible within a fixed budget and a fixed timeline. Okay, this is what the project manager of the software lifecycle will take care of. This is what is called the application release process. That is the main goal. So how do you do that? Obviously, that idea will have some requirements. Those requirements will need to be coded. And then that code needs to be tested. And finally, it needs to be deployed. In plain English, it is actually this. And then this life cycle, this goes on and on. Okay. If it is all good, then customer is happy. Now, the thing is, whenever you are coding it, this part, so once you code it, it has to be, so that is something called a source code. Okay, that creates something called executable file. Why? Because whenever you, we speak in many languages as human beings, but computers will always talk to each other in binary. When we will learn Linux, in Windows systems, it is called executable. In Linux system, it is referred to as binary. So these binary files are what is finally this binary or executable files. This is the code that has been written. Okay. This has to be configured on the server. This part is important. Who is doing this binary part? This part developer is doing. Who is configuring it on the server? This part traditionally ops team is doing. So how do you do that? For this, you will need to install tools. You will need to deploy the application. You will need to configure security or firewall. So all of these stuff here will be actually done by the ops team. Once this is done successfully, only then your app is running fine. Now, what is the problem here? I mean, like where does the problem actually arise? Ultimately, the objective would be to quickly deliver high quality code. Now, this is where the problem will start. Let me explain this. Try to understand this. The development team and the operation team, they are working, although they are working for the same project, they actually have different goals. The development team's job is actually to write the changes. Okay, but the operations team is to maintain stability. If you think about it, their job profile is actually against each other. Whenever developers will make changes, the system will become unstable. It will need to be tested. The security checks have to be done. There are multiple things that have to be done. So actually the developers and operations teams, they do opposite tasks, but for the same project, not exactly opposite, but one is trying to maintain the system, bring about stability. But whereas the other one, the developer is actually making changes so that which is directly causing the systems to become unstable. Now, once the developer writes the code, he has coded the application, that code operations team will need to deploy so that the application can be operated. But maybe the developer, the steps that he has to give some guide. Okay, that is called a release note. Maybe that guide was not well documented and the operations team did not understand it properly and deployed something. And finally, what happened? The software did not work. So now their development team will say it is working in my system, but when you are deploying, it is not working. So it is your fault. The operations team will say we are deploying it properly, you have not written the code properly. So this is the continuous fight that happens between the development team and the operations team. This is what happens in the traditional method. Now, this is where DevOps comes into the picture. As DevOps engineers, you will be speaking the language for both the developers and the operations team as well. You will be, if you remember, you will be in between. You will work as a liaison between the developers and the operations team. So you will help in infrastructure provisioning, you will help in deployment, you will help in code build, but you will not write code. Okay, so don't worry about that. We will not write code for development, but as DevOps engineers, we will definitely write code for building, for deployment, for provisioning. All these details go through the syllabus, which we have shared with you yesterday. In all of these things are distributed across those multiple major and minor projects as part of the 2-month course. So the DevOps engineer is actually someone who will speak the language of both the developers and the operations. There, as DevOps engineers, the methodology that DevOps uses, in that miscommunication or lack of collaboration, that is completely avoided. So that is the very high level thing about DevOps. Traditionally, apart from this, developers making changes and operations then trying to implement the changes, there is also a security. There is also going to be a security team who needs to make sure that proper protocol are being followed or not. Like maybe the company has got a protocol that all their systems, developer systems, they should be always connected to the VPN. And without that, no login should not work. Okay, so there will be security is always required for the safety of the company. So that in effect actually slows down the release process. But then once again, it is definitely necessary to keep your systems safe from hackers. So all of these create roadblocks. The purpose of DevOps is to actually remove these roadblocks. Initially, the things will be done manually, but once something has been identified, the steps have been identified, like for example, the scripts that I wrote for deploying the server. Once that has been identified, then it will be automated completely. So that is the purpose of DevOps. And like this is a very, very high level overview. You will get to learn all of this gradually as we proceed in the course. Now, on that note, I mean, like we have had a lengthy discussion for more than 1.5 hours now. So on that note, I will end the theory session now and practical as well. If anybody has any doubts, we are opening up the platform for your queries. Please feel free to ask your questions by unmuting or maybe on chat. Emmanuel, I'm done with the training. Now I've opened up the forum for Q&A.
All right, thank you very much, Kallol, for your time. If you have any questions, please do ask Kallol if you have any technical questions. All right.
Or
So
any non-technical questions also.
Yeah, we are going to discuss about this course duration and the fees now. Just 1 second.